So, Simeon's joining me in this capacity lesson. Maybe some other students will as well. This is for students who missed the lesson on finding the capacity of a cylinder. So, we have a cylinder, and this cylinder has a volume to it. It also has a surface area to it, and it also has a capacity. So when we look at this cylinder, it's really important that we are aware of how this cylinder works. There are, inside this cylinder, there are walls. There's a thickness to this cylinder. So what I mean by that is if I was to cut this cylinder in half, it would kind of look like this. This is a down view of it. If I was to cut this cylinder in half, this is actually kind of just not really quite in half. This is more like a wall of it. You can see that there is a thickness here to the walls. The walls are thick. And if I had a floor or a base to this, there would be a base to it as well. So where am I going with this? So let's have a look. This cylinder, there's like an outer cylinder here. But there's also, realistically, an inner cylinder as well. So it's like two cylinders in one. If I was to take this inner cylinder out, it would be a slightly smaller cylinder. And that's because there is a thickness to the base. There's a thickness to, perhaps, if there was a cap or a lid on it. And of course, there's a thickness to the walls. So this outer cylinder is bigger than the inner capacity of that same cylinder. So another little example, if I had, I'll do the ant example. If I had an ant, a little ant here, let's say the height of this cylinder is, I don't know, 20 centimeters. If this ant was to jump off the cylinder, it would land on the ground 20 centimeters below. It would fall 20 centimeters. Splat, falling 20 centimeters. However, if, let's say this cylinder, there was a lid here, and therefore the ant was inside the cylinder and hanging from the bottom of the lid, so let's put the lid here. Let's say the lid is 2 centimeters thick. Then the ant is actually 2 centimeters lower. So the ant is here, 2 centimeters lower. And let's say there's a thickness to the floor, the base. And let's say that's also 2 centimeters. So let's say here, there's a thickness to the base. So really, if the ant is inside the cylinder, the ant would be 2 centimeters less here and 2 centimeters less here. So it would only fall 16 centimeters, right? It would fall from here to here, so it would be 20 centimeters minus 2 centimeters minus another 2 centimeters. It would only fall 16 centimeters. So my height inside, so therefore the height of the inner cylinder is actually 16 centimeters. Now let's say this same ant is, we're going to do a bird's eye view. The same ant is looking, the same ant is on the top, and the same ant was to crawl on a tightrope across the cylinder. And let's say that the diameter of the cylinder is 15 centimeters. It would crawl on a tightrope from here all the way across the other side. It would move 15 centimeters to get to the other side. But let's also say that there is a thickness, as we suggested here, to the walls. So if there's a thickness to the walls, and let's say the walls are, I don't know, 1 centimeter thick, that means instead of the ant crawling from here, 15 centimeters all the way across, let's say the tightrope started here and went to the other part of the inner cylinder, it would actually be less 1 here and less 1 here. It would be 1 centimeter less on this side and 1 centimeter less on this side. So really the ant from the inner cylinder is only going 13 centimeters across. So that means the diameter of my inner cylinder here would only be 13 centimeters. So my new dimensions would be 13 centimeters for the diameter and 16 centimeters for the height. Whereas the outer cylinder, the diameter was 15 centimeters and the height was 20 centimeters. So 15 centimeters was the original and the height was originally 20 centimeters. Okay, that's